Okay folks, we're going to carry on looking at the C4 chemical calculations topic by introducing you to this concept of the mole, which is a very important concept in chemistry. Whenever you hear me talk about the phrase mole or use the word mole, it's all in chemistry. Don't get too confused with it, because a mole is just a number. 1 mole of any substance is this many particles of that substance. So if I had 1 mole of nitrogen molecules, I would have 6.022 times 10 to the 23 nitrogen molecules. If I had 1 mole of sodium ions, I would have that many sodium ions. If I had 1 mole of carbon atoms, I would have that many carbon atoms. So a mole is just a number. It's 6.022 times 10 to the 23. So it's 6022 and then 20 zeros after it. It's quite a big number. It's quite important for a reason I'm going to explain now. So I've got a chemical equation here, all right, and it is balanced, so don't worry about doing that. It's nitrogen plus hydrogen makes ammonia. Now, if I was to ask my chemistry technician to go and weigh these things, I mean, you might be thinking, and you'd be right, that that means 1 molecule of nitrogen reacts with 3 molecules of hydrogen. Well, molecules are very small and very light. It's impossible to weigh them. So what we've actually done, and this guy called Avogadro discovered this, is that we can actually say that rather than 1 molecule, if we say 1 mole of nitrogen needs 3 moles of hydrogen, and that will produce 2 moles of ammonia. So all I've done there is I've basically taken the big numbers at the front to let me know what the ratio is of my reactants to products. So now, rather than weighing 1 molecule, I can get my technician to weigh 1 mole of nitrogen. And that becomes something we can actually weigh. So the mole is very important for us to work out how much chemical we actually need for a given chemical reaction. Like I say, the next few weeks we're going to spend a bit of time looking at that. So I now know that I need to get 1 mole of nitrogen and 3 moles of hydrogen to actually react. But how much does that actually weigh? So there's a formula triangle here that I'm going to introduce you to. It's called mass over Mr. moles. So mass divided Mr. times moles. So what do each of these things do? Well, mass is just how much it actually, the mass of it in grams, so how much you actually weigh. The MR is the relative molecular mass. I'll just put relative mass for now, because it could be atoms as well. And moles is just how many moles you'd have. Because don't forget, if a mole is just a number, technically, couldn't you have half a mole, quarter of a mole, 1.759 moles? Of course you can, all right? It'd just be whatever that number is multiplied by 6.022 times 10 to the 23. So, back to this problem here. I want to work out how many grams of these two things my technician needs to weigh, all right? So she can go straight to the formula triangle, and right, so I want to work out grams, which is mass, cover up the triangle, and she'll notice it's moles times Mr. So moles times Mr, or Mr times moles, equals the mass. So times MR times MR. Okay, so how do we work out the MR of these things? Well, let's do some short calculations over here. So what is the MR of N2? Well, just counting all the different atoms in there. So in this molecule, I've got 2 lots of nitrogen. I'll check the periodic table. I'll look for the big number, all right, the top number for nitrogen. So 2 times 14 is 28. So I now know the MR of that is 28. And let's do the MR of hydrogen while we're at it. So hydrogen is H2. So in that H2, I've got 2 lots of hydrogen atoms. I'll check the periodic table again, and I discover that hydrogen weighs 1 atomic mass unit, and 2 times 1 is 2. So the MR of hydrogen is 2. So now I've calculated the MR, I will be able to work out, or my technician will be able to work out, how much of this particular substance she needs to weigh. So 1 times 28 is 28 grams, and 3 times 2 is 6 grams. And they're masses that we can, and they're things that she can actually weigh, all right? So she can actually go away and weigh these different masses. If she was asked to weigh just 1 molecule, very tiny, very light, impossible. We don't have the scales to do so. So again, it's quite important to be able to get to grips with this formula triangle. That's what you're going to spend this week's lessons working on. So it can also help you to work out how much product you should get as well. So we learned earlier that we should get 2 moles of this. Well, let's just work out how many grams that is. So I'm going to work out my MR over here somewhere. Let's do it here. So I've got NH3, I've got 1 N, and I've got 3 H's. Using the periodic table again, 1 times 14 is 14, 3 times 1 is 3, add them together is 17. So the MR is 17. And then I can do my calculation. So if I should get 2 moles of ammonia, I should get 2 times the MR, which is 17. So that equals 34 grams. Yeah. And those that are super observant out there will hopefully have noticed something. That you notice that 28 grams of nitrogen plus 6 grams of hydrogen will equal 34 grams of product. This proves, again, in a chemical reaction, the conservation of mass. So whatever atoms you have on the left of an arrow must equal the atoms on the right of an arrow. And this proves it. So this triangle does actually work in several different ways for us. Okay, so just going to pause the video just there. I'm just going to show you another few ways of how to manipulate this particular triangle. Okay guys, so I'm just going to show you first set of sort of calculations you can do with the formula triangle. It's converting mass into moles. All right, so I've got a couple of questions here. It says calculate the amount of moles in 38 grams of calcium oxide and 256 grams of H2O. So what am I trying to figure out in this particular question? It's the amount of moles. So I'm going to cover up moles and then work out what my calculation is. So moles is mass divided by Mr. Mass in grams divided by the MR. Okay, so in each of these questions, I've got a mass, but I don't have an MR. So let's do one question at a time now. So I need to work out the MR of calcium oxide. So what I've actually got here in this formula, I've got 1 calcium atom, 1 oxygen atom. Check the periodic table for the top number in each box. Calcium weighs 40, oxygen weighs 16. So the MR of calcium oxide is 56. Now, because I've got my mass and I've got my MR, I can work out moles. So moles equals the mass, which is 38 grams, divided by the MR, which is 56. Put them into a calculator. So 38 divided by 56, 0.68 moles. So that's how you can actually use it. So the only thing I had to do here is I was given a mass, I had to work out the MR of the formula. So if I told my technician, right, I've got 38 grams of calcium oxide, how many moles is that? They'd be able to calculate it like that because it's just moles, so mass divided by the Mr. And the Mr is just all the different atoms in the formula added together, all their masses added together. Let's try it over here then. So 256 grams of water. Well, I need to work out the MR of water. What do I have in the formula? I've got 2 H's and 1 O. Check the periodic table. Each hydrogen has a mass number of 1. So 2 times 1 is 2. Each oxygen has a mass number of 16. 1 times 16 is 16. Add them together. There's your MR. So the MR of water is 18. So now I can do my calculation again. Moles equals mass, which is 256. Grams divided by the MR, which is 18. So 0.256 divided by 18, 14.2 moles. Okay, and like I say, a mole is just a number. So if I had 14.2 moles of oxygen, I would have 14.2 times that water molecules. So it's quite a, and that would be a massive, massive number, but it's only 256 grams of water. So not too much water at all, really. It just shows you, again, how small atoms and molecules are. Right, let's pause the video there. I'm going to clean the board and do one further type of calculation with this. Okay guys, got a second type of question now. So this time we're not calculating the number of moles of something, we've actually been given the number of moles and we're asked to calculate the mass of a substance. So the mass of these substances. So how do you work out mass? We'll cover up mass in the triangle. It's mass equals Mr times moles, or MR times moles. In each question we're given the number of moles. So I need to work out the Mr of each to work out, to then work out the mass. So let's work out Mr. MR of Al2O3. So what have I got in this formula? I've got 2 aluminium atoms, or aluminium ions technically, 3 oxide ions. So using the periodic table, aluminium has a relative atomic mass of 27, oxygen is 16. 2 times 27 is 54, 3 times 16 is 48, add those together, 102, right? So, to work out my mass equals Mr, which I've just worked out, 102, times moles, which is in the question, and that will give you an answer. So that would be, just use my calculator to check, all right, 151, I think. Oh, sorry, 153. Yep, so 153 that would equal. So if I told my technician, go and get please can you go and weigh 1.5 moles of aluminium oxide, he or she would go away and record and weigh that many grams, 153 grams. Right, and let's do the final one over here. So 0.75 moles of potassium bromide. First things first, I need to work out what the MR of potassium bromide is. So I've got 1K, 1Br. Remember, in each element within each compound, each element is represented by a fresh capital letter. So you've only got 2 capital letters in a compound. There's only 2 different elements in it. So 1K, check the periodic table, that's 39. 1Br is 80. So that's 39 plus 80 is 119. So I can now go and work out the number of grams that 0.75 moles would be. So mass equals Mr, which is 119, times moles, which is 0.75, $89.3. So again, don't get concerned with the concept of a mole or worry about what the mole is. It is just a number, all right? It's just that number there. And you can actually work out and manipulate how many moles of a substance you've got by just using this formula triangle here, mass over Mr moles. And just like with most things in this topic, the more you practice, the stronger you become at it. Okay, hope this helps.